Hi, my name is Dr. Jenny Root, and I'm excited to be joining you today for the first webinar in our series on AI for adult educators. So let's look at a preview of what to expect in this series. So our first webinar is this one is focusing on introduction to AI, going over the AI fundamentals, some benefits, limitations, and some ethical considerations that we need to have in place before we move forward into thinking about specific applications of AI. So the future webinars, February, going to focus on AI for accessibility, March, AI for engagement, April, AI for executive functions, and May, AI for assessment. So here's an overview of this first webinar. We're going to talk about the fundamentals of AI, make sure that we have some common language and understanding of what it is and what it is not. We'll then talk about some benefits as well as the limitations and some ethical implications. I think what's important to note is that as I'm recording this in January of 2024, it's based on the information and the tools and the things available now. What's really exciting, but then what can also be somewhat frustrating about trying to gain skills in this area and use AI is that things are constantly changing. So, given that things are constantly changing, why now? Why should you, as an adult educator, put time, effort, and energy into learning about AI? Well, I want to start. You'll notice here I have a screenshot of a resource developed by the Office of Educational Technology out of the US Department of Ed. And this is a quote. It says, "I strongly believe in the need for stakeholders to understand the cyclical effects of AI and education. By understanding how different activities accrue, we have the ability to support virtuous cycles. Otherwise, we will likely allow vicious cycles to perpetuate." So those who've been in education for a while know that sort of things come around and they go. And while AI in many aspects is new, and many in other aspects it's not. It's not all that different from maybe the prior issues and concerns, barriers that we faced in any form of technology, assisted instruction, as well as just issues in education broadly, meeting the needs of various students and doing so in an ethical and responsible way. So I think it's important to first think about what are the educational benefits potentially of integrating and being proactive about AI. So it has the potential to improve learning outcomes, enhance teaching, and increase the efficiency and accessibility of our instruction. So one of the big drivers of the focus here is that perhaps we can use AI to support educational instruction and sort of maximize our resources. So, whereas there may only be one instructor in a course, and that then limits how much individualized feedback, the types of practice opportunities, the instruction that's provided, perhaps AI can help fill in some of that work and multiply the attention, the opportunities to respond, the opportunities for differentiation, the feedback that individual students get. However, as we are sort of thinking about these educational benefits, it's important that we are also proactively mitigating the risks and addressing the very valid concerns, both the concerns that we're aware of now, but then also being aware of as technology evolves, as we apply it and use it in different ways, that there are going to be ongoing concerns that may arise. One of which is to have the concern about systemic bias, the surveillance bias, and making sure that we have transparency about knowing how information is being used, what information the AI is pulling from. So this is one of the motivations of beginning the webinar series with really focus on the fundamentals of AI so that as we better understand it, we can then better understand where the limitations are and where the biases are and how we might be able to address that. There's also those well-known risks of data breaches and misuse. And then there might be risks as technology emerges about algorithmic discrimination, just meaning, how is the algorithm programmed to respond? And is that treating one group of individuals differently than another group of individuals? Or is that treating certain tasks differently than others? and then monitoring the risks of the spread of misinformation. All of this being proactive is intended to prevent some unintended consequences. So we need to acknowledge that there might be unforeseen outcomes, that there might be unforeseen risks, and also we might create or exacerbate some existing inequalities, right? So we know that there's differences in access to technology resources, access to Wi-Fi, to devices, and that if as we are leaning into technology and leaning into AI and using that as a solution for very real problems, it may not be an equitable solution. It might not be a solution that's fully attainable by everyone. And we need to be aware of that. Very, very similar to what we faced in the early days of COVID when it came to, we put everything remote, but then there's accessibility issues. We need to ensure that the systems are trained on high quality and unbiased data. And if that doesn't make any sense, like, what do you mean you're training a system? We'll talk about that in a few minutes. And then finally, all of this needs to emphasize, and what I hope you've picked up on, is the importance of human oversight and intervention, that AI can be, and tech in any form can be used to supplement and augment a teacher's role, but not to replace. All right, so let's go into the fundamentals of AI. I want you to begin by just reflecting right now. What's your initial reaction to that term, artificial intelligence? Is it exciting? Is it scary? Is it something that you're feeling reluctant about? So I want you to pause if you need to and think about, just sort of self-reflecting, what are the words that come to mind when you think about artificial intelligence? How does thinking about this make you feel? Okay, now we're going to watch some other video clips that do a really great job of giving an overview of AI and what it is. And then I'm going to get down into some details and give some examples.
Picture this, a machine that could organize your cupboard just as you like it, or serve every member of the house a customized cup of coffee. Makes your day easier, doesn't it? These are the products of artificial intelligence. But why use the term artificial intelligence? Well, these machines are artificially incorporated with human-like intelligence to perform tasks as we do. This intelligence is built using complex algorithms and mathematical functions. But AI may not be as obvious as in the previous examples. In fact, AI is used in smartphones, cars, social media feeds, video games, banking, surveillance, and many other aspects of our daily life. The real question is, what does an AI do at its core? Here is a robot we built in our lab, which is now dropped onto a field. In spite of a variation in lighting, landscape, and dimensions of the field, the AI robot must perform as expected. This ability to react appropriately to a new situation is called generalized learning. The robot is now at a crossroad, one that is paved and the other rocky. The robot must determine which path to take based on the circumstances. This portrays the robot's reasoning ability. After a short stroll, the robot now encounters a stream that it cannot swim across. Using the plank provided as an input, the robot is able to cross this stream. So, our robot uses the given input and finds the solution for a problem. This is problem solving. These three capabilities make the robot artificially intelligent. In short, AI provides machines with the capability to adapt, reason, and provide solutions. Well, now that we know what AI is, let's have a look at the two broad categories an AI is classified into. Weak AI, also called narrow AI, focuses solely on one task. For example, AlphaGo is a maestro of the game Go, but you can't expect it to be even remotely good at chess. This makes AlphaGo a weak AI. You might say Alexa is definitely not a weak AI, since it can perform multiple tasks. Well, that's not really true. When you ask Alexa to play Despacito, It picks up the keywords play and Despacito and runs a program it is trained to. Alexa cannot respond to a question it isn't trained to answer. For instance, try asking Alexa the status of traffic from work to home. Alexa cannot provide you this information, as she is not trained to. And that brings us to our second category of AI, strong AI. Now, this is much like the robots that only exist in fiction as of now. Ultron from Avengers is an ideal example of a strong AI. That's because it's self-aware and eventually even develops emotions. This makes the AI's response unpredictable. You must be wondering, well, how is artificial intelligence different from machine learning and deep learning? We saw what AI is. Machine learning is a technique to achieve AI, and deep learning, in turn, is a subset of machine learning. Machine learning provides a machine with the capability to learn from data and experience through algorithms. Deep learning does this learning through ways inspired by the human brain. This means through deep learning, data and patterns can be better perceived. Ray Kurzweil, a well-known futurist, predicts that by the year 2045, we would have robots as smart as humans. This is called the point of singularity. Well, that's not all. In fact, Elon Musk predicts that the human mind and body will be enhanced by AI implants, which would make us partly cyborgs. So, here's a question for you. Which of the below AI projects don't exist yet? A. An AI robot with citizenship. B. A robot with a muscular skeletal system. C. AI that can read its owner's emotions. D. AI that develops emotions over time. Give it a thought and leave your answers in the comment section below. 3 lucky winners will receive Amazon gift vouchers. Since the human brain is still a mystery, it's no surprise that AI too has a lot of unventured domains. For now, AI is built to work with humans and make our tasks easier. However, with the maturation of technology, we can only wait and watch what the future of AI holds for us. Well, that is artificial intelligence for you in short. Do not forget to leave your... Picture this, a machine that could organize your cupboard.
Okay, so I hope that that was helpful in giving sort of this broad picture overview of what AI maybe is in our minds, but then realistically where we actually are right now. I appreciate this graphic that demonstrates sort of the different aspects of AI. Again, this is also coming from that Office of Educational Technology report. And so you can see there's sort of different aspects. We have, the different types of AI, super, general, or narrow. There's different components. There's ways that they can be optimized. I frankly don't know what those are. I don't think those are important for us to fully understand. I think what's important is that there's many different components, and that AI is this like broad term that has a lot of different things under it. Speaking of terms, there's this fantastic resource, Circles, the Center for Integrative Research in Computer and Learning Sciences, that has terms. Now, you'll see from the screenshot, it's no longer being updated. So there might be new terms that don't show up there, but I really appreciate how comprehensive it is, at least at this point in January of 2025, and that the terms are really done in simplified layperson language. So again, a lot of these resources are going to come from this report, and so it's a good resource to go back to. So when we think about different perspectives on AI, it's sort of like different lenses that we use to think about it might help us to understand in different dimensions. So the idea of human-like is helpful because it can be shorthand for that idea that computers now have capabilities that are very different from the capabilities of early EdTech applications. Educational applications will be able to converse with students and teachers, co-pilot how activities unfold in the classroom, which makes sense in Microsoft named theirs Copilot. And also be able to take actions that impact students and teachers broadly. There are going to be opportunities to do things better than maybe we are able to do today, or maybe at a larger scale, but there's also going to be risks that we need to anticipate and address. But the human-like reasoning shorthand is not always useful, because AI actually processes information differently from how people process information. So when we kind of just like, oh, it's human-like, and we don't address how people and computers are different, then we may enact policies or make decisions that have unintended consequences. So while having that human-like reasoning perspective is beneficial, it's limiting. So pattern recognition capabilities and automated recommendations can be used in ways that impact the educational process, like student learning, teacher instructional decision making. For example, personalized learning systems may recognize signs that a student is struggling, and they may then recommend an alternative instructional sequence. So the scope of that pattern recognition and automated recommendations is likely to expand. But it's humans who have to determine the types and the degree of responsibility. How much of that decision making are we going to hand over to technology versus how much is going to be, staying within the realm of a human. That's not really a new dilemma. Intelligence augmentation is idea that centers intelligence and decision making in humans, but recognizes that people sometimes are overburdened, might benefit from assistive tools, right? So I like to think of this as what can tech, or what can AI do that a teacher could do, but is perhaps automating it or making it more efficient, increasing the capacity, so that then teachers do what only they can do. Or if you think about this other way, people do what only a person can do. So AI might help a teacher make a better decision because the computer notices patterns that a teacher might miss. So maybe a teacher and a student agree that a student needs reminders for something, like reminders for staying on task, or a reminder for something, to be due. The AI system might be able to provide those reminders in whichever way the student wants. So maybe able to choose it's a push notification on your phone, or it's an automatic email that comes from the learning management system. It's a message that comes directly as a text, for example. So intelligence automation is going to use the same basic capabilities of AI, looking at associations in the data to notice patterns, and then through automation, it's going to take actions based on those patterns. But intelligence augmentation, thinking of it that way, focuses on helping people in human activities of teaching and learning. Whereas AI, thinking of it that way, really focuses the attention on what the computers can do. Okay, so the important thing to take away then is AI, think of it as automation based on association. So when computers automate reasoning based on associations and data, or associations deduced from expert knowledge, right? So people had to feed the data and give it the algorithms. There's two shifts that can occur. One, we can go from technology just capturing the data to detecting the patterns in data. And then we can also shift from providing access to instructional resources, using technology to access instructional resources, to using technology to automate decisions that we make about instruction and other educational processes. So detecting patterns and automating decisions are really far leaps when it comes to the responsibilities that we could delegate to a computer system. But if we look at sort of the timeline, AI, if we think about that as the ability of a machine to imitate intelligent human behavior, has been around since the 1950s, right? But then at that point, this mantra of like, computers do what they are programmed to do and they can't do anything more. By the 1980s, we then began to have the application of AI that allowed the system to automatically learn and improve from experience, and that is machine learning. So as machine learning developed and evolved by the late 2000s, early 2010s, we then began to have deep learning. And that's the application of machine learning that uses a complex algorithm and deep neural nets to train a model. You might think like, what do we mean? These are computers. We're not in an ocean. We're not fishing. What do you mean by a deep neural net? What is the model that we're training? I will attempt to make that more clear for lay audiences like me, who this is all pretty new information. But I think the important shift to understand is that we have had the ability of a machine to imitate intelligent human behavior for a long time, since the 1950s. But it was predicated on this: computers do what they are able to do, what they're programmed to do, and nothing more. That's not true anymore, or there's a potential for that to not be true anymore. We can see just the huge growth in the publication of things related to AI based on field of study. And so you can see like linguistics have been using it for a while. It's not really all that more, it's not really increasing. But what has increased as far as research is AI's ability for pattern recognition, machine learning, learning vision has really kicked off with smartphones. So things like Google Lens. So let's go through these sort of this big umbrella category of artificial intelligence, with the definition of that being the ability of a machine to imitate intelligent human behavior. So, and then we'll talk about machine learning, which is like that aspect of artificial intelligence, and then deep learning, which is a type of machine learning. So as reviewed in the video, AI can be thought of as narrow or weak as one type of it. And that's when it is designed for a specific task with a narrow range of abilities. That's when the tech is really just simulating human behavior based on that limited set of parameters, constraints, and context. So the computer can only do what the computer can do. Weak AI excels at like a particular task. So strong AI then is able to have broader understanding and reasoning capabilities. Weak AI are things that have limited decision making. So the systems only rely on pre-programmed rules and data to make decisions within their specific domain. So we can think of those as completely reactive or having sort of a limited memory capability, but it's not learning from itself. There's no self-awareness. Weak AI doesn't possess consciousness or the ability to understand its own actions or anything like that. So the key points being that weak or narrow AI has a narrow focus. It's really a specific task. There's limited decision-making and no self-awareness. So here's some examples of narrow, weak AI. One being Google Lens, another being Siri. The predictive content on Netflix. So Netflix sees what you have previously watched, and then it's going to suggest other things. One of my very favorite things now is when you Google something, Gemini, which is Google's AI persona, it almost like summarizes that for you and gives you links and examples. So the input that I put here was I said, what are some examples of chatbots, of applications of chatbots? And so you can see here that the chatbots examples are an example of narrow weak AI. So for example, you go to order a pizza from Domino's, a little chatbot pops up. If you're trying to book a train ticket through Amtrak, right? So any of those chatbot features are an example of limited or narrow, weak AI. A spam filter. So it just has a rule. Emails from these senders or these keywords go to spam. Another example would be your Facebook feed and targeted ads. Interestingly, self-driving cars are also considered narrow or weak AI. And you might think like, that's so innovative, it's brand new, how can that possibly be narrow or weak? But remember, it's about it's being designed for a specific task, as a narrow range of abilities, and there is no self-awareness. And then finally, the one that I am plagued by would be autocorrect text fails, right? So that is AI being predictive about what it thinks that you meant to send and trying to anticipate those errors. So 2 questions I want you to consider are, how do you use narrow or weak AI in your personal life? So do you go with the suggestions that are based on, that Netflix gives you? Do you have a spam filter? Do you engage in social media? Do you use Siri? Do you have a smartphone that has autocorrect? In that case, you have interacted with, you do use AI. So I feel pretty confident in saying that probably 98% of adults in the US right now regularly use AI, even if they're not aware of it in their personal life, but also in your professional role. Are there, as you're thinking about this, are there existing AI systems or things built into your workload and your um, uh, tools that you use in your job, like a spam filter? So probably all of us use AI, not only for our personal life, but also for our professional roles, because it's just embedded now in our ways of work. So there's narrow or weak AI, and the second category is general or strong AI, and that's when it is designed to think, comprehend, learn, and apply intelligence to solve problems. This is the current focus of tech companies, but it does not currently exist. So if you hear general and strong AI, they're essentially the same term. What it's talking about is this hypothetical type of artificial intelligence that has broad cognitive abilities similar to humans, right? So to contrast with narrow or weak AI, where it's designed for a specific task with a narrow range of abilities, general or strong AI has broad cognitive abilities. It means it's capable of learning, reasoning, solving problems across a wide range of domains. Sometimes it's also called artificial general intelligence, AGI. It has these human-like capabilities, so it's able to mimic, in theory, it would be able to mimic a full spectrum of cognitive abilities, common sense, problem solving, adaptability. It would have a broad application, just like as humans are able to broadly solve problems. But again, right now it's considered a future goal. There's not an existing, as of January 2025, there's not an existing AI system that fully reaches this level of general intelligence. It's very interesting that what it's relying on is a theory of mind AI framework. So those of you, maybe if you've viewed some of my prior webinars, been to my workshops, and we talk about theory of mind being an aspect of autism spectrum disorder. Meaning the ability to take the perspective of another person, understand that a person even has a different perspective from you, and being able to make inferences about that. And so it makes sense then that AI is the tech development is focusing on developing this theory of mind framework. So the tech being able to go beyond predictive text or autocorrect, where it's just using patterns and words to anticipate what you might be thinking or saying or wanting to communicate, and going to actually being able to infer what I would want to do and doing it autonomously. And then finally, so if this general AI doesn't exist, then super AI is not comprehensible, meaning we can maybe watch a science fiction movie about it or dream about it, but it is a very far way off. We don't even know enough about our own brains to be able to develop an artificial one. Okay, so we have these artificial intelligence, AI. It's that ability of a machine to imitate intelligent human behavior, and there's the three levels. Within that, we have machine learning. So given that currently the super AI doesn't exist and generalized artificial intelligence doesn't exist, everything that we're currently working on is narrow or weak AI for machine learning. So there are three components of machine learning. And again, that's the application of AI that allows a system to automatically learn and improve from experience. So three components are: one, the decision-making process. So this algorithm produces an estimate about a pattern of inputted data. That's the really key part. Someone, something, somehow, the tool has to be given the data. It is not independently, autonomously getting that. Second key component, so it has to have some sort of decision process. There's some sort of algorithm. So we use our spam box example. It produces an estimate about, is this email spam or is this the focused content? I think is what Outlook calls it. And the error function is like, how often does it get it right? And then model optimization is, okay, if we're making a whole lot of errors, how can we update the algorithm and change the algorithm and the decision process to avoid that error in the future so that it's learning and improving? So there are three types of learning that machine learning can enact. Okay, so supervised learning is the first. That's when they are able to calculate outcomes based on labeled data. Let's talk about what do I mean by labeled data. That's when the data that the AI, the tool, uses is labeled with the correct output. So it's the model learns by comparing predictions to outcomes and adjusting appropriately. And I'll give some examples. So the type of problem that this would address is classification. So being able to predict a discrete label. Is this spam or not spam? Is it a spam call or not a spam call? Uh, so the other type would be regression, so predicting continuous values. Zillow. Zillow is a great example where Zillow looks at the labeled data, the inputted data of the house prices, for example, and then it can predict a continuous value. So it can say what they call it the zestimate is. Okay, so supervised learning is when you have labeled data and you're either classifying that, so you're saying like, oh, that's spam or not spam, or so those are dichotomous, or there's this continuous value, like I'm going to predict weight loss, I'm going to predict home value. A second type of learning is unsupervised learning. So supervised makes sense, outcomes based on labeled data. Unsupervised learning is underlying patterns and groups data that's unlabeled. So in this case, it's working with data that has no predefined labels. It just sees everything that you write and then creates groups or structures. So the types of problems that it can solve are clustering, so grouping similar data points together. Fraud alert, for example. So your credit cards, your banking companies use this type of AI to be able to determine is that probably a fraudulent charge or not. Right. So the difference is why is fraudulent charges unsupervised learning? Because it's not labeled. So the labeled data in this example would be just charges. And maybe I can predict based on the charges you've had about how much you might spend next month. Or I can put it into categories, right? So some credit cards might say you spent this much on shopping, this much on food, this much on like travel, gas. Well, that's based on it knowing, what that charge was or what type of establishment it came from. Unlabeled data, it's just seeing all the charges and it's trying to notice, is that, a higher value than usual? Is it from a location that you've not been? Are there a whole bunch of charges, happening over and over? It looks for those patterns and then groups it. And then the other type of unsupervised learning is association. So it's being able to discover the interesting relations between variables. In this case, predicting what you might like to watch on Netflix. And so it is looking at that unlabeled data. It doesn't know what I like and don't like. Sure, there's like you watch the show, you didn't watch the show. But within the shows that you do watch, it's able to look at patterns, how long you may have looked at something, the types of things that you looked at, and it's grouping them and adjusting what you see, similar to Facebook feeds or a TikTok algorithm. Okay, so we have supervised learning. We have this labeled data, and we're just categorizing it or making sort of predictions based on the values we have. We have unsupervised learning, which is where the data that the algorithm receives is not labeled. So it doesn't know, is this a fraudulent charge or is this a charge that was really intended to make? So it looks at the patterns and sort of starts looking for outliers or grouping them. And finally, reinforcement learning that's where there is a series of actions to achieve a goal. In this case, you don't have to have labeled data. You could be labeled, could not. And that's where the algorithm is learning from the feedback received from actions. So the model is taking actions in that environment to maximize reward over time. So you can think about this as mimicking trial and error, right? So here's some types of problems. Exploitation versus exploration. So if you think about it, you want to go to a restaurant and you want to go out to eat. Exploitation is the example of you go to the same one that you know is good every day. You might miss out on a good one, but it's going to go ahead and recommend the one that it thinks has a high likelihood of success. Exploration is where maybe it's going to suggest restaurants you haven't been to before, but you're probably going to have a good experience. So the key part is that it's only with reinforcement learning that the model is learning from the actions. Okay, so all of another way to represent machine learning. So we have unsupervised learning, supervised, and reinforcement. And then if you take a look at all these different examples of how that's applied. So targeted marketing is an example of clustering unsupervised learning. Um, uh, Identity fraud detection, right? We talked about that with supervised learning, reinforcement learning, being able to have games or robots, that can learn from, something of the Roomba. Oh, I'm bumping into something, so it's not going to keep going there. So now I want you to take a pause, similar to as we did with just like broad AI. I want you to think about, how do you use machine learning in either your personal life or your professional role? Okay, so we have artificial intelligence, machine learning, and then deep learning, which is the application of machine learning with complex algorithms, deep neural nets to train a model. So what I want to do first in order to explain the difference between machine learning and deep learning is show you this graphic. So machine learning, there has to be some sort of input, and then a human has to have be involved in the feature extraction and helping it know what to do. So machine learning uses algorithms to teach computers to perform tasks. So that output. However, deep learning is a subset of machine learning where you notice it goes straight from input to the feature extraction and classification, right? So instead of having to have those as two separate sets, it is one. And so the deep learning uses artificial neural networks to automate complex tasks. So key difference is that deep learning requires more data than machine learning. It takes training time. So meaning the deep learning systems have to have more time, more data in order to be able to develop the patterns needed to get the correct output. Deep learning then requires less human intervention than machine learning. It also requires much more computational power than machine learning. So sort of big picture differences between them. When it comes to deep learning, there are sort of four common uses or applications of it. Again, deep learning uses these artificial neural networks with multiple layers. That's why it's called deep, to learn from the data. So one example of deep learning is image recognition, things like using Google Lens. A second is natural language processing. That is the ability of computers to understand, interpret, and generate human language. So for example, AI powered language translation tools. Speech recognition is an example of deep learning. So being able to use not just using voice to text, but for example, if you have like an Amazon Alexa in your house and it can tell, your voice from your partner's voice or your child's voice. So we use our Alexa at home to make a shopping list. So anytime I notice like, oh, we need applesauce, I can tell it to add applesauce to the list. And what's interesting is I go to my app and go to my shopping list and it'll say who added it. That's that speech voice recognition. And then finally, self-driving cars, right? So we've talked about self-driving cars being an example of weak AI or narrow AI. It's also machine learning and it's also deep learning, right? Because we have these concentric circles. So here's an example of the difference again between machine learning and deep learning. So let's say with machine learning, you provide a child with a set of labeled pictures, right? So for example, this is a dog and this is a cat. And you explain the key features of each animal. So, like dogs have 4 legs, fur, usually a tail. A cat might have claws. Their ears are normally more pointy, might have a longer tail, right? We point out the differences between them. So the child then learns to identify new animals based on these specific rules and features. Deep learning. And so the key part there is there's explicit instruction and what those features are. And then we learn over time by seeing examples and non-examples. But there was the explicit feature instruction first. In deep learning, we might just show children lots of pictures of different animals. So we might not explicitly tell them their features, right? So the child might observe the subtle differences between different animals without explaining their features. So we're just wanting them to sort of pick up based on all this data input. So the child would observe these subtle differences, shape of the ears, texture of the fur, the way they move, and over time, that child might develop an intuitive understanding of what constitutes a dog or a cat, even if they can't articulate what those specific rules are. So that would be the difference between machine learning. We'd have this rule feature extraction that then the technology rolls with, versus deep learning, where it has the ability to sort and classify on its own. So again, here's the key differences between them. You want to think of machine learning as a broader concept, an umbrella term, about teaching computers to learn from data without being explicitly programmed. It uses algorithms to analyze the data, identify patterns, and make predictions. It can work with both structured and unstructured data, but often there needs to be some sort of preparation, feature engineering, this would be things like spam filtering, product recommendation, fraud detection, simple image detection or recognition, like basic objects. We then get into deep learning, which is that subset of machine learning that uses AI with multiple layers. It excels at complex tasks involving unstructured data, like more complex images. So thinking like Google Lens, or there's an app I know of that you can put it on a plant. It'll tell you like whatever that is, or on a picture of food, and it can give you example recipes. So that it involves unstructured data like images, audio, natural language. It requires large amounts of that data in order to be able to train, right? So by training, we mean it's seeing those various images of different types of cats and dogs, and it needs lots of examples to be able to form those categories. So these are things in like more complex image recognition, facial recognition, object detection in images. Again, natural language processing, so like translations, speech recognition, and self-driving cars. So here's just another analogy. So like if we teach a child different shapes, circle, square, triangle, you provide examples and rules and they categorize them. Deep learning, like teaching a child to recognize faces, they learn by observing countless examples and gradually developing an understanding of the facial features and how they combine. Why does this matter for teachers and adult educators specifically? Well, you don't need to become AI experts, but you should grasp these fundamental differences between machine learning and deep learning. I think it's also important that you have an awareness of the applications, so understanding how these technologies are being used in education. So when you hear, oh, it's AI or it's personalized learning, AI-powered tools, hopefully, sort of having the schema in mind will help you be a more informed consumer of those things. And we know that data is really important in the learning process for students, that data is how uh, that is something we value in order to be able to assess how well a student has learned something. I think it's really important that we remember data. Just like computers used to be, that a computer can only do what it's programmed to do. Right now, AI is only as good as the data that it was trained on. So that leads to some ethical considerations like bias, but broadly more the use of data, privacy concerns. So the process of developing an AI system, developing the algorithm, deciding what data to train it on, what are the expected outputs, what's that margin of error, it can lead to biases in how patterns are detected and unfairness in how decisions are automated. So educational systems have to govern their use of AI systems. And there are that Department of Ed Tech Report does a really good job of starting to recognize what are the challenges that we've already identified and the things that we need to be aware of now. And then hopefully that's going to be something that is continually revised for further policy guidance and development. Okay, so let's jump into thinking about the benefits of AI in adult education. So the process of okay, so we have the familiar technology capabilities. So what are things that technology and AI can currently do, and then where might it go? So, for example, we are very familiar with the inputting data, telling computers what to do by typing, clicking, dragging, the touch screens, the gesture controls, right? But perhaps we are going to get even better technology that allows us to speak and has better voice recognition. Right now, there's a lot of limitations for people who might have speech and language impairments, dealing with accents. Perhaps, you know, I don't know if you've ever seen those virtual tablets, like Remarkable or Supernote are two of them, and you can write and then it has handwriting recognition and you can convert it to text. That is getting better and better and better, as well as being able to analyze images and videos. So right now we use technology for displaying information and tasks, sequencing activities, checking student work. The hope is that we're going to be able to use AI to actually assist in the teaching and learning process, things like personalized learning tutors, planning and adapting activities. Again, being able to have the technology do what a teacher could do should they have optimal resources and training and background and time, so that the teacher can only do, or so the teacher can do what only the teacher can do, right? Because tech cannot replace people. And then finally, we think about what's the output that we get from tech. We are used to, of course, you get text, Word documents, graphics, pictures, multimedia. Super popular now are dashboards, particularly in school system work, where we can take all of that data and it houses it in one place and maybe visually displays it for us. But perhaps in the future, those outputs can be things like generated conversations. Even now, there's a program that called Notebook LM from Microsoft that can take any article that you upload and turn it into a podcast. So it can take, let's say you found this research article, put it into Notebook LM, and it uses two simulated voices. So they are not real people, but they have trained on enough podcasts to know sort of like what's the banter, what's the back and forth, what's the format, to then simulate conversations. So instead of having to actually read the article, you can just listen to this fake podcast about it. So ultimately, the benefit to learning that I see right now and that's most exciting to me is adaptivity. So it's the way that technology can improve the learning for things like personalized learning paths. So perhaps AI algorithms can analyze learner data to create a customized learning journey. It would facilitate and make more efficient differentiated instruction where the learners receive content and support tailored to their specific needs. In theory, that's going to lead to faster progress and improved outcomes. Another exciting piece to me potentially is real-time feedback and assessment, so that AI could serve the same purpose as a teacher or a tutor sitting right next to the student, or the learner, somebody who can, they can ask questions of it. It can give models and examples. Automated assessment, certainly freeing up time of both the creation of the assessment and the scoring of the assessment. Improved accessibility is where we've seen a lot of improvements rapidly as tech improves at the same time that the algorithms improve, meaning like the devices that we use. So tools like text-to-speech, speech-to-text, real-time captioning enhances accessibility. AI-powered translation tools might help facilitate learning for people from different language backgrounds, so that that is no longer a barrier. Or, if students, maybe they might have English proficiency, but being able to also present information in multiple languages. And then finally, we want to think about enhanced engagement and motivation. So by personalizing the learning environment, hopefully we're able to get that like optimal amount of challenge, make sure that we're staying within the zone of proximal development. I like to think of it as the Goldilocks test. So how can AI help to make sure we have that just right balance of challenge and support? Many tools are currently exploring how to use principles of gamification in order to personalize learning and enhance engagement and motivation. So I want to give you an example of an AI-powered tool from Khan Academy. It's designed to act as a personalized tutor for students. So it gives customized guidance and feedback based on their individual learning needs. So very similar to what a human tutor would do. It can also then assist teachers by generating lesson plans and analyzing student progress. And so this was just featured on 60 Minutes with Anderson Cooper, but I want to show you just a quick video teaser.
Hi, I'm Conmigo. Let's meet some great teachers, just like you.
I teach chemistry.
IELD students, the English language learners.
6th grade math.
Computer science. I teach high school math.
I'm a student teacher.
Please tell us more.
I have to lead 3 different types of classes, and I have to come up with how I'm going to teach the curriculum. And that's a really daunting process, but having Conmigo, it's a really helpful assistant to kind of put all those pieces together. We're doing gas dynamics, and we're teaching it through the lens of climate change. How can I make that real for my students? And so I might ask Conmigo, give me a hook for starting our unit on the chemistry of climate change. And it'll give me 4 or 5 options.
I like that I can ask Conmigo a question or say, hey, I need like an easy, a medium, and a hard. And so it can help me develop my lesson plan into 3 different categories where instead of going to multiple websites or looking for different resources, I can do it all in one location.
It really helps with differentiating the instruction for all the kids.
Yeah, it saves me a lot of time. Not having to do the groupings, it does it for me. Conmigo kind of takes care of the initial blank white page, gives me that starting point.
From start to finish, just faster.
Could save 20-30 minutes a day times 5, so I was kind of blown away by that.
If I wasn't going to use Conmigo, then I'd have to search for all these different activities or these exit tickets or questions.
Okay, so I don't want it to be quite a commercial advertisement for Conmigo, but this is one example of the types of tools that we'll be diving more into and thinking about over the course of the webinar series of how to best utilize that specifically for adult learners with disabilities. So the benefit to teaching of automation, I think, is an area we should be cautiously optimistic about. One recommendation of the Office of Educational Technology is to make sure that we are centering educators, that we're not in these processes. And when we think about automation, that's really why it's really important for educators to be at the table when it comes to policy making, as well as product development and product scaling and selection, to make sure that we're thinking about educators and their needs so that we are using tech to support the teaching, the preparation of the teaching, the evaluating the tools for teaching and learning, but to make sure we keep a person at the middle. I did find this data really interesting as far as how do teachers spend their time. These are teachers in the US. I'm sorry, these are, average for Canada, Singapore, UK, and US. So an average of 50 hours of working time per week. And if you see, only about 49% on average is actually direct interaction with students. So are these other areas where we could decrease effort and time spent on things like preparation or administrative tasks, evaluation and feedback, so that more time can be spent on student instruction engagement, or crazy thought, maybe teachers just work their contract hours for which they are paid. So the last video that I want to show to give an example of how sort of the future of AI and what its capabilities are, is I want to watch a short video talking about large language models, LLMs. That is what many of the AI tools you might think of off the top of your head, things like Microsoft Copilot, Gemini, ChatGPT, they are all large language models. So let's take a look at this.
When you ask artificial intelligence, like ChatGPT, a question like, what is the best way to slice bread? It provides an answer that seems like a human expert. The AI appears to know about types of knives and that bread is heated when cooked. Does AI really know these things? How can it know about so many topics? Can we trust the answers? To answer those questions, let's look at the source of the information used by tools like ChatGPT, large language models. Imagine the task of scanning every word on the internet. That's every blog, website, research paper, book, newspaper, computer program, and more. That's the goal of massive computers that power tools like ChatGPT to capture everything it can on the web. This snapshot of over 1 trillion words creates the foundation for large language models. By analyzing the words in the model, ChatGPT can answer our questions and requests with human-like quality. What sounds like expertise is really a math problem for artificial intelligence. It works because powerful computers are trained to look for common patterns between words and phrases, like tomorrow morning, cup of coffee, and suppose that you. Large language models can also detect context. It can tell, based on words that appear together, if you mean bat or bat. Every word becomes a math problem that uses artificial intelligence to find what word should come next in a sentence. So, when we ask AI how to slice bread, it doesn't know about bread or knives like you and me. It only knows the words in the large language model. Because it was trained on 1 trillion words and their context, it can assemble the words that most often answer that question. Keep in mind that AI responses are based on what's published on the internet, and like the internet, they can be biased, misleading, and inaccurate. Evaluate and use them with skepticism and care. With experimentation, when you ask artificial
Okay, so there are some limitations, though, of AI, at least as it currently exists. Probably the biggest limitation that I am faced with in my role as an educator is limited guidance. So there's limited federal guidance, which really these are state level decisions, but there's limited state level guidance for K-12 educators. And guidance from various institutions, state colleges or universities. So the CITL, the CITL Center, which I'll feature some of their resources throughout this webinar series, they are a federally funded center that the focus is to support teacher educators or people who teach teachers in technology use and integration. But they also they're going to have fantastic resources for you as adult educators who aren't in university settings as well. And what they do is they looked at the state level guidance for K-12 education. And so they had just looked across all the states to see, did they provide a document or a resource from someone with authority? And they have a couple emergent themes. So one, the things that we've already talked about, the potential of personalized learning, the importance of identifying potential risks, ethical use, advocating for this human-centered AI, or thinking of it as intelligence augmentation, the need for making sure that we're looking at equitable access and reducing bias, the need for human training, and us being at the table for policy development. So we say that there's little guidance. The states in green meet that guidance requirement. So they had something out that said guidance and it met the CITL Center's inclusion criteria. Yellow states, they have guidance, but it didn't meet the requirements. And all of these gray states don't have any state level guidance or didn't in late 2024. Of the guidance that's available, again, these are sort of the themes of guidance that you can find. I do want to point out a limitation to adaptivity that is really important to know and to keep in mind as we're thinking about the potential uses for adults with disabilities. And I think it's important that we know that AI is only as good as the models are only as good as the data that they are trained on and the algorithms that they are given. And so if as we're building these systems, we aren't really thinking about all aspects or the variability of human learning, then it's going to have limited adaptivity. And then it's going to have, I love the Siddle Center called this brittle or narrow supports, right? And so if we want more broad and strong supports for learning, we want better adaptivity, it all comes from the top of whether all variations of human learning and human performance are being considered as we're developing these models. So ultimately, we really need expansion in AI models instead of thinking about a deficit-based view to asset-oriented. So this was noted in the Siddle Center's report that often adaptivity is focused on deficits. It's focused on when individuals aren't doing well and there's a problem. But I think that we can also think about how to use their strengths, their assets, how to increase challenge as well. But the models can't be any better. They won't be fully equitable if we aren't really thinking about every student's sources of competency and variability. I think right now, one limitation is that AI models are really only focused on individual levels of cognition and not looking at those social, the motivational, cognitive elements of learning, despite the fact that AI does have all this potential to increase motivation and engagement. Related to, are we really thinking about the broad spectrum of human thinking, and the variability is that models right now, just like any aspect of our instruction, is based on neurotypical expectations and behaviors versus having a neurodiverse viewpoint and approach of, instead of saying like, oh, these people are doing fine, but those are going to need something else, thinking about all the ways that everyone might be variable. This is a new concept to you. In some of our prior webinars, I've presented on neurodiversity and kind of dived more deeply into that. And then finally, instead of having just like fixed tasks with correct answers, that many aspects of adaptivity don't only have to do with something being correct. We can also think, does the pace need to be faster or slower? Does it need to be a different type of learning? Right and wrong answers aren't the only learning goal. We might also want students to self-regulate, be able to set goals, evaluate whether they've met the goals, persist in working on difficult problems. And so it will be important that AI models in the future, if they're really going to realize what all of those benefits are, that they do more than just think, was that the correct, numerical answer to the math problem? And finally, I want to end on looking at ethical implications. So the 4 recommendations from the Office of Educational Technology, as far as thinking about equitable access, is to center people, so that we're thinking about the people who are going to be using the tools and who are going to be benefiting from the tools, making sure that the tools that we're using are safe, effective, they responsibly use data, that we have transparency, we know how the data is being used, we know the models that it's being trained on, and potential limitations. So to ensure more equitable access, we need to think about what are the disparities in resource access that might exacerbate existing inequalities. So access to, broadband, high-speed internet, Wi-Fi availability on our campuses, the computing power. So it's not just you have a device, but is your device capable of using these tech tools? And so as we consider, where are the disparities, how can we make sure we're bridging that digital divide, as well as addressing any potential biases in those tools that might disadvantage one group over another? Protecting learner data, our individual data, is incredibly important. And this is at policy levels, or when you think about adapting different tools, these are things that you want to consider. What is their data security and privacy like right now? How is the data used and shared? Who can potentially access it? And if it is using an individual student's data, and that data is then being kind of added to the model, that we know that ahead of time. Ultimately, we need policies that are going to help us leverage that automation to advance learning while protecting the human decision-making and judgment, not taking the teacher out of it. It's important that we're able to integrate or interrogate, excuse me, that underlying data quality in AI to make sure that the outputs that we're getting are useful and appropriate for the task. We also need to look at how different AI technologies can increase or undermine equity for certain students and take some steps that we can to safeguard that. I mentioned the CITL Center, again, the Center for Innovation, Design, and Digital Learning. This is an excellent resource. I'm going to be featuring them throughout this webinar. They've been, especially early on, my primary source of being able to stay in the know. They have this report, Inclusive Intelligence, the Impact of AI on Education for All Learners. I wouldn't say it's a report, it's like an ebook that also might be helpful if you'd like to go ahead and learn more. So as we're thinking about looking forward before the next webinar, I want you to think back to at the beginning of this, what you thought about, like your initial reaction to artificial intelligence. And I'd love to know, or have you reflect on how your thinking may have changed just over the past hour and a half or so that we've been together. And then to look forward, begin to prepare for AI integration. So play with, learn, use your AI technology. I think that we often don't just play and try out things enough. Districts and schools and universities often adopt something. Maybe a few people, piloted or played out, but there's this like, oh, here's a new thing we're using, go use it, without time to just play and get comfortable with it. So if you've never used ChatGPT before, if you've never used a image lens, something like Google Lens to be able to image detection, download it and try it out and just see, maybe it's useful for you. As you begin to playing with it, you want to think strategically about how you might want to use AI to support adult learners with disabilities. And I hope that this webinar series is going to help you be strategic about that. So this concludes the first webinar in the series on Intro to AI. Up next in February, we're going to be focusing on AI tools for accessibility.